Good afternoon. I am Kavina Abhivikrama from the Aeronautics Society of Royal College Colombo 7, and I will be your host today. Before we start today's event, I would like to remind our participants to keep their microphones muted and refrain from typing in chat throughout the event. Firstly, the welcome speech. I'd like to welcome our principal, Mr. P.A.S.P. Jayalath, the Senior Master of Clubs and Societies, Mr. T.D.C.P. Amratunga, our teacher in charge, Mr. W.H.A.D. Sumanga, members of the Prefects Council of Royal College, our chief guest for the event, Mr. Santhusha Ravihara, as well as the chairman and top board of the Aeronautics Society, and last but not least, I would like to welcome all of our participants to the first phase of the annual lecture series 2022, Fundamentals of Flight. Now, I would like to introduce you to our guest speaker. Mr. Santhusha Ravihara is a theoretical knowledge instructor at Lakwin Flight Academy, as well as a commercial pilot license holder. Being an old royalist, he was a member of the 2016-17 Senior Prefects Council and was also the chairman of our very own Aeronautics Society back in 2015. So, without further ado, I would like to invite Mr. Santhusha Ravihara to begin his presentation. On to you, Aya.
Right. Thank you, Manli, for the introduction. I think I'm audible enough for everyone. Am I correct? Am I clear enough?
Yes, Aya, you're audible.
Right. Okay. So I don't think I'll need a big, big something about myself since Assistant Chairman Manli introduced me very well. Anyways, I just begin by saying a few words. So. First of all, thank you for the opportunity. Like, thank you for inviting me. I'm always like very glad to be back. Anything that's happening at school or anything like that, right? And especially as a part of the Aeronautics Club, or back in the day during our time, it was called Aviation Society, right? So yeah, as he said, I was the chairman in the club in the year 2015, and I went on to be a senior prefect in the school as well, so spent a bit of extra time there. And before I begin today, so I was informed there are like students from grade 6 to 11 today. That's correct, right? Yeah. So first of all, I want to let you know that I don't want this to be like a lecture student thing, right? So where I explain something, you listen, you nod, and you stay all silent, right? I don't want this to be something like that, right? And also, I'll be using both English and Sinhala mediums, right? So I'll be using both languages here and there. And if you do have any questions, right? So if you do have any questions, you are always free to bring it up in any of the two languages, Sinhala or English. That's fine, right? So yeah, and today I was asked to do fundamentals of flight. So basically, we sometimes call it principles of flight, right? So what I'm going to do today is, right, since I'm a theoretical knowledge instructor as well, right? So we use some training software. I will be taking you through one of these softwares, right? So I'll be explaining to you with this, right? Remember this, since there are like kids from grade 6, I'm telling this, so there can be parts that might be a bit complicated. I won't be doing so much complicated stuff. I'll be just doing a small introduction to what the theory is, and then I'll explain a bit on that. Maybe I'll show a video or two after the session is over. And also, please bear in mind, as we are all experiencing power cuts these days, I just came out of a power cut. So if I go off like all of a sudden without any notice, could be one of those. I'll try my best to get back to you, right? Anyways, okay, so I want you all to talk with me as well, right? So don't just stay silent, ask questions even in the chat box. That's fine, right? So I hope you'll ask questions. That's how we all learn, right? Okay, I'll share my screen now. right. Sorry. හරි අපි නම් පටන් ගමු. බලනවා ඇති අයි මේ paint එකක් open කරගෙන ඉන්න background එකේ කියලා, right? I have I'm using paint to draw certain things if I want, right? And this is this software that I told you about, right? I'll be using this, right? So what you are looking at is actually what you do if you start PPL, right? So this is one of the subjects that you do under PPL. PPL is the private pilot license, right? So in that you have certain modules, and this is one of the modules, principles of flight, right? So before we actually go into this, I just want to see what kind of an idea you have when it comes to planes, right? So anyone here, I'm expecting the senior students. 11 වසරවල වල ඉන්න මල්ලිලාගෙන් එහෙම පොඩ්ඩක් බලමු. මම හිතනවා ඔයගොල්ලෝ දන්නේ නැති කියලා. කියන්න බලන්න කවුරු හරි දන්නේ කෙනෙක් ඉන්නවා නම් පොඩ්ඩක් කියන්න ප්ලේන් එකක් උඩ යන්නේ කොහොමද කියලා අදහසක් තියෙන කවුරු හරි ඉන්නවද මෙතන? කතා කරන්න පුළුවන්. දන්නේ නැත්නම් ප්‍රශ්නයක් නැහැ. මෙතන ඔයගොල්ලෝ ඒක ඉගෙන ගන්න තමයි අද ඇවිල්ලා ඉන්නේ. මෙතන දැනට මේක ගැන මොන හරි අයිඩියා එකක් තියෙන කෙනෙක් ඉන්නවා.
When lift and what do you call it? Lift and thrust like merge. I mean, like the plane flies.
Yeah, so lift and thrust are there. Anyone? Okay, due to lift forces. Okay, so yes, due to lift, there are 4 forces. If you didn't know, right? For in an aircraft, there are 4 forces. The 4 forces are called the lift, the thrust, the drag, and the weight, right? So lift is what's acting up, right? So lift is what's acting up. If you take the aircraft like this, right? I'm drawing on a mouse, so my drawings will be bad. Apologies in advance, right? So if this is the aircraft, right? In here, you are going to have 4 forces, right? So this force, this is what we call the lift. This is what's keeping you airborne, right? This is what's keeping you flying, right? And then this is your thrust given by the engines, right? That drags you, that pushes or pulls you forwards, right? And then you have the drag. Drag is the resistance that you feel, and then this is the weight of the aircraft. Weight is always acting down, right? So this is what basically, these are the 4 fundamental forces, right? So this is where you start with lift, here drag, weight, and the thrust, right? Okay, this you know, good, very good, right? So you met Malli grade 7. For grade 7, this is very good, right? Okay, anyone who has any idea how these forces are created? Okay, yes, the aircraft is flying with these forces. These are the 4 forces that we are talking about today, right? Anyone here who has an idea how this lift, let's say lift, how is this lift created? So how is this
From
thrust
the
created?
aerofoil in the wing.
From the aerofoil in the wing. Okay. Any other answers? That's the lift. What about the thrust, the weight, the drag?
From the engines.
Okay, thrust is coming from the engines. Anything else?
It's created by the pressure differences in the wing, which pulls the plane up.
Okay, that was a more advanced answer. Yes.
For that you need some speed.
Okay. Okay, good. Anything else? No one said anything about the drag or the weight.
The weight is created by the gravity.
Created by the gravity. Okay, when you come to O-level, A-level levels, A-level levels, you will learn that that definition we say is wrong, but you can't say it's created by gravity. It's something that happens due to gravity. But yeah, I'll accept that, right? What about the drag?
By the fraction made by the wind.
What
Air
fraction?
molecule.
Air molecules. Air molecules contribute to thrust lift as well. Without air molecules, you wouldn't have the lift, you wouldn't have the thrust, right? So an aircraft can't fly in space, right? So if you go to space, you know, where satellites are, where, you know, spaceships are, an aircraft can't fly, right? So you need the air molecules for all these things to happen. For the weight, you don't need the air molecules, you just need the gravity and the components of the aircraft. But for the remaining three, thrust, lift, and drag, without air molecules, those three won't be present. So an aircraft will not be able to fly in space, not even in space above a certain altitude, right? Above a certain height. බීම ඉඳලා යම් කිසි උස ප්‍රමාණයකට ගියාට පස්සේ එතනින් උඩට යන්නත් බෑ ප්ලේන් එකකට. right? ඇයි? මොකද එයා මොලිකියුල්ස් නැහැ. අපි උඩට යන්න තියෙන එයා මොලිකියුල්ස් ප්‍රමාණය අඩු වෙනවා. ඒක අඩු වෙනවා කියලා කියන්නේ ඔයාට ඒක මෙන්න මේ ෆෝසස් ටික ඔයාට මේන්ටේන් කරන්න බැරි නම් ඔයාට ෆ්ලයි කරන්න බෑ. right? හරි. කට්ටියට ඒ කියන්නේ ෆියුටි නොලෙජ් එකක් තියෙනවා මොනවාද ෆෝසස් ටික කොහෙන්ද එන්නේ කියලා. ඕගොල්ලෝ කිව්වා ලිෆ්ට් එක එන්නේ වින් එකෙන් කියලා. ත්‍රස්ට් එක එන්නේ එන්ජින් එකෙන් කියලා. හරි. ඒ ඕගොල්ලෝ කිව්වේ එන්න තැන. right? මේක හැදෙන්නේ කොහොමද? එක්කෙනෙක් කිව්වා ප්‍රෙෂර් ඩිෆරන්ස් එකක් කියන්නේ. right? එක්කෙනෙක් කිව්වා ප්‍රෙෂර් ඩිෆරන්ස් එකක් කියන්නේ. එතකොට හරි ප්‍රෙෂර් ඩිෆරන්ස් එකක් තමයි එන්නේ. ලිෆ්ට් එක කියන්නේ එක විදිහක ප්‍රෙෂර් ඩිෆරන්ස් එකක්. ත්‍රස්ට් එක කියන්නේ එක විදිහක ප්‍රෙෂර් ඩිෆරන්ස් එකක්ම තමයි හරියට බැලුවොත්. right? ඉතින් ඔන්න ඔය ටික වෙන්නේ කොහොමද කියන එක තමයි මම අද ඔයගොල්ලන්ට කියලා දෙන්නේ. හරිද? මොනාරි ප්‍රශ්න තියෙනවද?
නෝය.
ඕකේ. අපි යමු අපේ software එකට. මම කිව්වා ප්ලේන් එකකට fly කරන්න බෑ. air molecules. වාතය කියන දේ නැත්නම් ප්ලේන් එකකට උඩ යන්න බෑ. right? ඉතින් අපි ප්ලේන් එකක් උඩ යන්නේ කොහොමද කියලා ඉගෙන ගන්න කලින් මේ වාතය, වාතාශ්‍රය අපේ ඇට්මොස්ෆියර් එක ගැන අපි ඉගෙන ගන්න ඕනේ. right? ඉතින් ඇට්මොස්ෆියර් එක ගැන පොඩි ඉන්ට්‍රොඩක්ෂන් එකක් දෙන්නම්. ඔයගොල්ලන්ට මේකේ ප්ලේ වෙන එක ඇහෙනවද? ක්ලියර් මදි නම් වගේ පොඩ්ඩක් කියන්න.
එක්ස්කියුස් මී අයියා හොඳට එනවා අයියා මේ අයියා ඔක ඩවුන්ලෝඩ් කරගන්න එහෙම වෙබ්සයිට් මොකුත් කියන්නේ Google එකේ වුණා ඩවුන්ලෝඩ් කරන්න පුළුවන්ද?
මේක මල්ලි ට්‍රේනින් software එකක්. මේක සාමාන්‍ය ෆ්ලයිට් ඇකඩමිස් වල විතරයි තියෙන්නේ. මේක ඩවුන්ලෝඩ් කරන්න බෑ එහෙම. මේක මමත් ඉන්ස්ට්‍රක්ටර් කෙනෙක් හින්දා ඕගොල්ලන්ට මේක මට පෙන්වන්න පුළුවන්. නැත්නම් මේක සාමාන්‍යයෙන් එහෙම ඩවුන්ලෝඩ් කරන්න පුළුවන් දැන් නැත්තේ නැහැ. ඒ කියන්නේ ටොරන්ට් වගේ දේවල් වලින් මේව හොයාගන්න පුළුවන්. හැබැයි වට හොඳම වැඩේ තමයි ඔයාට මේකේ තියෙන කන්ටෙන්ට් එක ඕනේ නම් මේක YouTube එකේ තියෙනවා. right? මේ ඔයා මෙන්න මේක නිකන් සර්ච් කරන්න මේ මොකද මේක සබ්ජෙක්ට්ස් PPL level එක ගත්තොත් සබ්ජෙක්ට්ස් 8ක් තියෙනවා. ඒ සබ්ජෙක්ට්ස් 8 නම ගහලා මම මේක ලෙසන් එක ඉවර වෙද්දි මම මේ chat box එකේ හරි කොතනක හරි දාන්නම් ඒ සබ්ජෙක්ට්ස් 8 මොනවද කියලා. ඒ සබ්ජෙක්ට්ස් 8ට CBT කියලා සර්ච් කරොත් මේ CBT එකෙන් ගත්ත ක්ලිප්ස් ඔයගොල්ලන්ට YouTube එකේ බලන්න පුළුවන්. ඒක ඔයගොල්ලන්ට එහෙම කරන්න පුළුවන්. එහෙම නැත්නම් මේක ටොරන්ට්ස් වගේ වලින් නම් ගන්න පුළුවන් කියනවා. ඒක ඉතින් ගැරන්ටි කරන්න බැහැ ටිකක්. right. මේකත් කතා කරනවා. මම යා කතා කරන එක වැඩි ප්ලේ වෙන්න දෙන්නේ නැහැ. මට අවශ්‍ය තැනින් නවත්තලා මම කියලා දෙන්නම්. right? okay.
Answer lies
right. Whatever the aircraft that you are taking, right? If it's an aircraft, it maybe it can be a fighter aircraft. It can be a passenger aircraft. It can be just a small Cessna that you train on, right? All of these aircraft, there is one common thing, right? They need atmosphere. They need air, right? Without air, you can't produce thrust. Without air, you can't produce lift, right? So if you don't have those two, then you can't fly, right? Simple as that. So now let's talk about a few properties in the atmosphere, right? So in the atmosphere, we measure the atmospheric conditions in three metrics, right? So the three metrics are the pressure, temperature, and density, right? What are the three metrics? Pressure, temperature, density, right? Pressure කියන්නේ පීඩනය කොච්චරද? temperature කියන්නේ උෂ්ණත්වය කොච්චරද? density කියන්නේ ඝනත්වය, right? වායු ඝනත්වය කොච්චරද, right? ඔය දේවල් වලින් තමයි ඕගොල්ලොන්ගේ atmosphere කියන දේ measure කරන්නේ. ඔන්න ඔය properties තුනේ. right?
An atmosphere is defined as
atmosphere එකක් කියලා කියන්නේ ඒක අපිට විතරක් තියෙන දෙයක් නෙමෙයි. right? ඕනම planet එකක ඒක තියෙන්න පුළුවන්. right? එතකොට අපේ atmosphere එකක් තියෙනවා. අපේ atmosphere එකේ අපේ වායු අංශු තියෙනවා. air molecules තියෙනවා. right? These air molecules are held in place by gravity. right? They are not flying anywhere. They are not blown into the space. They are held around the Earth by the gravity. Right? So without the gravity, we will not have an atmosphere. Right? Without the gravity, we will not have an atmosphere. It will just blow into the free space. Right? That's what happened to Mars. Right? අඟහරු ගත්තොත් අඟහරු වෙලා තියෙන්නේ ඔන්න ඔය වගේ වැඩක්. එයාලගේ gravity එකම විතරක් නෙමෙයි. තව magnetic field එකක් නැති හින්දා solar radiation එක ඔය atmosphere කියන දේ එළියට ගහගෙන යනවා. Right? මාස් කියන එක ඒ දවස්වල තිබිලා තියෙන හොඳ ඇට්මොස්ෆියර් එකක් දැන් ඒක නැහැ ඔන්න ඒ හේතුව හින්දා. ඉතින් අපි ඉන්නේ හොඳ ප්ලැනට් එකක අපි ඉන්නේ ඒක එහෙම වෙන්නේ නැති ප්ලැනට් එකේ ඉන්නේ. right? ඒක එහෙම වුණා නම් ප්ලේන් එකක් යන්න තියා අපිට ඉන්නත් බෑ. අපිට ඉන්නත් බෑ ඇට්මොස්ෆියර් එකක් නැති. right?
being the gaseous envelope.
Right. So this atmosphere, this numbers you might have seen, right? This atmosphere contains 78% nitrogen and 28% oxygen, right? These two are the most abundant gases in our atmosphere, right? Oxygen 21%, that's what we breathe, and then we have an inert gas called nitrogen of 78%. The other gases, the numbers can change, right? So these numbers are not updated numbers. Now new numbers could be a little different than this, but these two are still the same, right? Oxygen is what we breathe in, and also what aircraft uses to produce power. Right? So you might have not thought about this before, right? Not only aircraft, your car also needs oxygen. If oxygen was not there, your car will not run, right? So if oxygen was not there, you can't live, and your car can't run either. Same story goes for an aircraft as well. An aircraft can't produce thrust without oxygen because it burns oxygen in the engine to produce the thrust, right? Without oxygen, there is no thrust.
There are many more gases. There is clouds.
Right. And the other thing, right? So we talked about 78% oxygen, 21% oxygen, sorry, 78% nitrogen, 78% nitrogen, 21% oxygen and all that. ඔය අපි ගත්ත percentages වලින් අඩුම ප්‍රමාණයක් තියෙන water vapor, ජල වාෂ්ප කියන දේ. හරිද? ජල වාෂ්ප කියන දේ තමයි හැබැයි අපේ atmosphere එකේ ලොකුම effect එකක් දෙන්නේ. right? ඇයි? දැකලා තියෙනවද බලාකුළු? වහිනවා. ඒ ඔක්කොම මොනවාද? වතුර. right? We will not have any weather without water vapor. අපිට හුලං එන එක එන්නේ නැහැ සාමාන්‍ය ගොඩක් වෙලාවට අපි clouds කියන දේවල් වගේ නැත්නම්. ඒක හැදෙන්නේ නැහැ water vapor කියන දේ නැත්නම්. right? එතකොට මේ water vapor කියන්නේ තියෙන චූටිම ප්‍රමාණයක් atmosphere එකේ. හැබැයි atmosphere එකේ තියෙන ලොකුම effect එක තියෙන්නේ මේ water vapor කියන දේ හින්දා. වහින්නේ නැහැ, clouds නැහැ. ඒ කිසිම දෙයක් නැහැ water vapor කියන දේ නැත්නම්. අපිට කාල ගුණයක් කියලා දෙයක් තියෙන්නේ මෙන්න මේ වතුර ජල වාෂ්ප තියෙන හින්දා. right? We will not have any weather without water.
And rain are examples of its liquid, whereas
liquid form is clouds and rain, right? Cloud එකක් කියලා කියන්නේ වතුර ගොඩක්, right? උඩ පාවෙවි තියෙන වතුර ගොඩක්. එතකොට වැස්ස කියලා කියන්නේ ඒකෙන් අපිට ලැබෙන වැස්ස. එතකොට ඔක ඔය liquid form එකනේ, right? ඕකේ solid form එකක් තියෙනවා. හිම ice ඒවා solid form එක. ඝන තත්ත්වයේ තියෙනවා. ලංකාවේ නම් එච්චර නෑ. ලංකාවේ කොහොමදත් නෑ, right? එනට පිට රටවල ගොඩක් සීතල පැති වල එන හිම ice කැට කියන දේවල් වැටෙන්න පුළුවන් බලාකුළු වලින්, right? ඒවා ඒකේ ඝන අවස්ථාවේ තියෙන දේවල්. වතුර වල ඝන අවස්ථාවේ.
the relative.
right.
The
මේ structure of the atmosphere කියන්නේ අපිට atmosphere එකේ structures layers වගේක් තියෙනවා, right? මේවා ගැන නම් ඔයගොල්ලෝ අපේ lesson එකට ලොකු අදාළත්වයක් නැහැ. හැබැයි ඔයගොල්ලෝ දැනගන්න ඕනේ දේ තමයි planes කියන දේ යන්නේ මෙන්න මේ level එක වගේ වෙනකන් විතරයි. මෙතනින් එහාට සාමාන්‍ය planes වලට යන්න බෑ. right? මෙතනින් එහාට සාමාන්‍ය planes වලට යන්න බෑ. ඒක මොකද මම කිව්ව ඉස්සෙල්ල හේතුව මේ උඩට යන්න මොකද වෙන්නේ? අපිට තියෙන air molecules ප්‍රමාණය අඩු වෙනවා. right? The amount of air that we have as we go higher and higher, it's keeping on reducing as we go higher and higher, and we lose the ability to fly, right? So you won't see aircraft flying above this level. Training aircraft will not leave this troposphere, the first layer, right? commercial aircraft, Airbuses, Boeings, they can go in the lower levels of the stratosphere, but not more than that. There can be some fighters that can go up to maybe here, but that's all. Right? It can't go beyond that. If you want to go beyond that, you need not an aircraft, a spacecraft. Right?
Aircraft are limited to flight in the troposphere and the stratosphere.
Right. Right. So I told you about 3 metrics in the atmosphere. Right? Can anyone remember what the 3 metrics are? Anyone here who remembers what the 3 metrics are?
Temperature,
Mm-hmm.
density,
Mm-hmm.
humidity.
Not humidity. Humidity is one, but it's not one of the main ones, main 3.
Okay.
You said temperature and
Density.
density. Okay, there is one more. Anyone who remembers what the next one is?
Pressure.
Pressure. Yes. Right. So temperature, density, and pressure. Right. So first we are talking about the temperature. Right. Who here has gone to New Delhi? Right. I think everyone here. Right. So what's the temperature at New Delhi?
About 15 Celsius.
Above 15 Celsius. It's much colder than Colombo or any other area, right?
Yes, sir.
Have you ever thought why?
Sir, I know.
Like I have thought, but I don't get the answer.
Sir,
Sorry?
it's because
I have thought, but I've always wondered why Noor area is cold and not Colombo. But I
Because it's located in a
the answer.
higher land.
Very good. It's located in a higher land, right? The temperature of New Delhi is low because it's located at a higher land, a higher elevation, right? So that's what happens in the atmosphere, right? That's what happens in the atmosphere, right? So on the ground level, you have a certain temperature, right? And as you keep on going up, right? As you keep on going up, what happens to this temperature? The temperature will decrease, right? That's why New Delhi is cold, right? And then you have colder countries, like if you take UK or any, even the northern parts, the Russia or the northern Europe, that area, those areas are cold, right? Those areas are cold because they are at a higher latitude, right? ඒගොල්ලෝ ඉන්නේ equator එකට කියන්නේ සිංහල term එක මතක නැහැ ඒකේ equator. අපි ඉන්නේ equator එකට ළඟ. මට සිංහල වචනේ හරියටම නෝට් නෑ මේ වෙලාවේ. right? මම කොහොමද කියන්නම්. නැත්නම් මතක එක්කෙනෙක් ඉන්නවද මෙතන?
sir, සමත්
අන්න සමකය.
සමකය.
right? අපි සමකයට ආසන්නයි. අපි සමක ආසන්න රටක්. ඒ හින්දා අපිට ඉරේලිය කෙලින්ම වදිනවා. right? ඒ හින්දා අපිට අපේ උෂ්ණත්වය වැඩි, අපේ ටෙම්පරේචර්ස් වැඩි. right? අපි උඩට යන්න මොකද වෙන්නේ? අපි ඉන්නේ globe එකක, අපි ඉන්නේ sphere එකක. sphere එකේ උඩට යන්න මොකද වෙන්නේ? අපිට ඉරේලිය වදින්නේ කෙලින්ම නෙමෙයි පොඩි angle එකකින්. right? අපිට ඉරේලිය වදින්නේ කෙලින්ම නෙමෙයි පොඩි angle එකකින්. අපි මේක කියමු ඉර කියලා, මේක කියමු earth එක කියලා. මේක තමයි පෘථිවිය. right? එතකොට මෙන්න මෙහි කොහේ හරි ඉර තියෙනවා. right? ඒක මොකද වෙන්නේ? කෙලින්ම ඉරේලිය එනවා මෙහෙම. මේ ඉස්සෙල්ලාම වදින්නේ කොයි හරියද? equator එක තියෙන හරිය තමයි කෙලින්ම වදින්නේ. right? ඒ වුණාට මේ හරිය මොකද වෙන්නේ? මේ හරිය එක පොඩ්ඩක් angle එකකට භාගයට වදිනවා. right? ඔන්න ඔය හින්දා තමයි උත්තර ද්‍රවය දක්ෂිණ ද්‍රවයේ ඒ කියන්නේ උඩ යට දෙකටම ඔක තමයි වෙන්නේ. right? ඔන්න මේ දෙපැත්තේ මේ උඩ යට දෙකම සීතලයි. ඒ සීතල වෙන්න හේතුව තමයි ඔන්න ඕක. right? අපිට රස්නේ එයාලට සීතලයි. right? මේක වෙනම කතාවක්. right? මේක වෙන්නේ උස වැඩි වෙන හින්දා නෙමෙයි. මේක වැඩි වෙන්නේ ඉරේලිය වදින angle එකේ හින්දා. right? This is happening because of the angle of the sunlight, not the actual height above the ground. Right? No matter what your area is, right? So if you are either close, you can be close to the pole, you could be living close to the equator, right? No matter where you are, whatever the temperature you have at the surface, right? Whatever the temperature you have at the surface, when you are leaving the surface and going up, your temperature will decrease, right? උඩට යන්න ඔය කොහේ හිටියත් බිම ඉන්නකොට තියෙන එක උෂ්ණත්වයක් උඩට යන්න ඔකට මොකද වෙන්නේ? ඔය උෂ්ණත්වය අඩු වෙනවා, right? ඇයි එහෙම වෙන්නේ කියලා දන්නේ කෙනෙක් ඉන්නවා. උඩට යන්න අපි නිකන් we are getting closer to the sun, so we should get more heat, right? එහෙම හිතන කවුරුත් නැද්ද? උඩට යන්න අපි ඊටට වැඩිපුර කිච් වෙනවා. ඒ හින්දා අපේ රස්නේ වැඩි වෙන්න ඕන කියලා.
Cold. Because the space is cold and but the air molecules near the earth is hot because the heat emitted from the earth.
Yes. Space is cold. Space is not technically cold, right? If you are in the direct sunlight in space, you could be at a much higher temperature than you are at surface, right? So that's a different scenario. That's way too advanced. But yeah, generally we consider the space to be cold, right? But if you are directly facing the sunlight in the space, then your temperatures are high. That's a different case. Please forget about that. But what you said last, yes, air molecules are getting their heat from the earth, not the sun, right? ඔන්න ඕක ඔයගොල්ලෝ දැන් අලුතෙන් ඉගෙන ගන්න දෙයක් වෙන්නේ නැති, right? earth එකට එන sunlight එක earth එකෙන් absorb කරනවා, right? මෙයාගෙන් එන sunlight එකට මොකද වෙන්නේ? මේක earth එකෙන් absorb කරනවා, right? ඊට පස්සේ මොකද වෙන්නේ? මෙයා රත් වෙනවා, right? මෙයා රත් වෙනවා. ඊට පස්සේ මෙයා මොකද කරන්නේ? මෙයා මේ රත් වෙච්ච එක මෙයා එළියට දෙනවා, right? ඔන්න ඕකෙන් තමයි අපේ atmosphere එක රත් වෙන්නේ. Right? When this is the heat source for atmosphere, not the sun. Right? It is sun indirectly, but the immediate contact is with the earth. Right? So further away you are from the earth, the colder you are. Right? Further you are getting away from the earth, the colder you get. Is that understood? Right? මේක මෙහෙම වෙන්නේ ඇයි කියන එක පොඩ්ඩක් complex. Right? ඒක ඔයගොල්ලෝ සමහර විට නිකන් ඒ ලෙවල් කාලේදී වගේ ඉගෙන ගන්න හම්බ වෙයි. මේක ඇයි මෙහෙම වෙන්නේ? ඇයි මේ ඉඩෙන් මේක රත් වෙන්නේ නැතුව ඇයි මේක earth එකකින් රත් වෙන්නේ කියන එක පොඩි complex mechanism එකක් එතන තියෙන්නේ, right? මම ඒක දැන් කියන්න යන්නේ නැහැ. හැබැයි මෙන්න මේක තමයි වෙන්නේ, right? උඩට යන්නයි සීතල වෙන්නේ. මොකද අපි earth surface එකෙන් අයින් වෙනවා. We are getting away from the earth surface, so temperatures are reducing. Further we are out from the heat source, the colder you are. Is that clear? Boys, is that clear?
Yes, sir.
Right. Okay. So temperature change with increasing altitude is, yeah, decreasing your temperature. Further we are getting away from the earth's surface, the colder you are.
The earth is heat.
Right? එතකොට pressure එකට මොකද වෙන්නේ? pressure එකට වෙන්නේ ඔය ටිකම තමයි, right? අපේ වටේට atmosphere එකක් තියෙනවා, right? මේ තියෙන අපේ atmosphere එක අපි එක point එකක් ගත්තොත් මෙතන තියෙනවා, right? අපි මෙතන එක point එකක් ගත්තොත් මෙන්න තියෙනවා ඒ point එක. මේකට උඩින් අපිට air molecules තියෙනවා. දැන් ඔයාට උඩින් ඔයාගේ ඔළුවට උඩින් මෙහෙම air molecules තියෙනවා, right? ඔය air molecules ඔක්කොම ඔයාගේ ඔළුව උඩට මෙහෙම තද වෙලා තියෙනවා, right? ඒ ඔයාගේ ඔළුව උඩ තමයි මේ තියෙන්නේ, right? එතකොට මේ බර ඔක්කොම ඔයාගේ ඔළුව උඩ තියෙනවා, right? ඔය බරට තමයි අපි ඔය බර අපි area එකෙන් බෙදුවම ඒ එකට තමයි pressure එක කියලා කියන්නේ, right? මේ ඔත්ත දැන් ඔයාලගේ ඔළුවට උඩ බරක් තේරෙනවද? Do you feel any pressure, any weight on your head? Anyone? Hello? So I heard someone saying something, I didn't hear what it is. Do you feel any weight on your head?
Yeah.
Yes? Who feels a weight on?
Don't know.
No, sir.
We don't get any weight on the head, right? We are used to that. That's what we call the atmospheric pressure. We have a pressure around us and we are used to that, so we don't feel it anymore, right? So that's the atmospheric pressure. When you are going up, what happens? The amount of air that we have on top of you reduces. The amount of air that you have on top of you reduces, right? So when that happens, the pressure decreases. So temperature is decreasing when you are going up, pressure is decreasing when you are going up, right? What about the density? Density, I have already said, as you are going higher and higher, the amount of air molecules we have is getting lesser and lesser, right? So your density is getting lowered as well, right? Your density is getting lowered as well. එතකොට ඔය තුනටම මොකද වෙන්නේ උඩට යද්දී? ඔය තුනම අඩු වෙනවා. Right? Pressure, density, temperature. All three decrease when you are going up. Right? Is that clear?
Yes, sir.
Okay. Now let's get back to this quickly because we have a limited amount of time as well.
A force.
Right. Then you have the units of measurement, those you don't need,
It was
and then density.
similar.
You can see closer to the ground you have more air molecules, these blocks are air molecules, and higher you go, lower the amount of air molecules you have. Your density is reducing.
To pressure.
Right. Then we have water molecules, humidity. ඉස්සෙල්ලා මල්ලි කෙනෙක් කිව්වා humidity කියලා. Right? Yes, humidity is another factor that we can measure. Right? Humidity කියන්නේ කොච්චර වතුර තියෙනවද අපේ ඇට්මොස්ෆියර් එකේ, කොච්චර water vapor ප්‍රමාණයක් තියෙනවද අපේ ඇට්මොස්ෆියර් එකේ. Right? So humidity is a measure of the amount of water vapor in an atmosphere. Right? Anyone here? Right? I'm going to ask a question now. Right? If you have more water vapor in the atmosphere, what will happen to the weight of that air? Will it increase or decrease?
Decrease.
Decrease or increase? You have more water in the atmosphere, right? So let's okay. I'll say this like I'll tell you this. Tell you like this. So let's say I have two parcels here, two parcels of air, right? In these two boxes, I have air molecules, right? I can fit 100 molecules in this, and I can fit 100 molecules in this, right? In this box, you have air molecules only, right? In this box, you have air molecules only. Air only. In this box, you have air and water vapor. මේ දෙකෙන් මොන එකද වැඩියෙන් බර? මේ දෙන්නගෙන් කවුද වැඩියෙන් බර?
The one with air and water vapor.
The one with air and water vapor. Any other answers? I mean, there is only anyone who disagrees with him. Right. You might think that this one, as that Malini said, you might think that this one has more weight on it because there is water in it, right? There is water in it, but this water is in the gas form, not the liquid form, right? මේක තියෙන්නේ ජල වාෂ්ප හැටියට, වතුර ජලය හැටියට නෙමෙයි, right? එතකොට මොකද වෙන්නේ? මේක සාමාන්‍යයෙන් O level කරන කෙනෙක්ට වගේ නම් මෙන්න මේක තේරෙයි, right? අපි ඉස්සෙල්ලා කිව්වා අපේ ඇට්මොස්ෆියර් එකේ වැඩිම තියෙන මොනවාද? ඔක්සිජන්, නයිට්‍රජන් කියලා. නයිට්‍රජන් කියන්නේ මෙන්න මේ ගෑස් එක, N2 කියන ගෑස් එක. right? ඔක්සිජන් කියලා කියන්නේ O2 කියන ගෑස් එක. දැන් මේකේ තියෙන්නේ ওই ටික විතරයි. right? ඔය දෙකට නම්බර්ස් තියෙනවා. නයිට්‍රජන් එකක අර මාස් යුනිට් එක කියලා කියන්නේ අපි. right? මාස් යුනිට් එක කීයද? 14යි. The atomic mass unit of nitrogen is 14. right? So 2 nitrogen means 28. right? For oxygen it's 16. So 2 oxygen atoms means this is 32. right? grade 6 7 ඉන්න මල්ලිලාට සමහර වෙලාවට මේක තේරෙන එකක් නැති වෙයි. වැඩි ගණන් ගන්න එපා. O level ආවම ඉගෙන ගන්න. right? What about water vapor? Water vapor is H2O. right? Oxygen එකක් තියෙනවා, hydrogen දෙකක් තියෙනවා. 2 hydrogens, 1 oxygen. 2 hydrogens means mass unit of the atomic weight unit of hydrogen is 1. So you have 2 there, right? For oxygen it's 16. So 2 plus 16. This is 18. Then මොකද වෙලා තියෙන්නේ? Both nitrogen and oxygen molecules are heavier than the water molecule. right? මෙයාට 18යි මේ දෙන්නටම 32යි 28යි දෙන්නම වැඩි යට වඩා. මෙයාට දාන්න පුළුවන් 100යි. මෙයාට දාන්නත් පුළුවන් 100යි. මෙයාගේ 100 ඔක්කොම තියෙන්නේ මේ දෙන්න. මේ 100 මෙන්න මෙයාගෙනුත් ටිකක් ඉන්නවා. මොකද වෙන්නේ එතකොට? බර අඩු වෙනව නේද? එතකොට you might think that water vapor, since it has more water vapor, it might be heavier. But in reality, this is a very interesting thing to note. The one without any water vapor will have the highest density, right? This will have the highest density. Water නැති එකේ තමයි density වැඩි. Understood? තේරුණාද? Right? In real life, water is heavier than air because this is a liquid, right? This is a gas. Gases are obviously lighter than liquids, right? But if you were to convert these also into liquids, we can get liquid nitrogen, we can get liquid oxygen. If you get the liquid form of these, then these will be heavier than water. That's what we are basically trying to say. Is that clear?
Yes, I.
Okay, so I think that's enough for the properties of the atmosphere, right? And before we finish the atmosphere, I'll tell you one more thing. There's one more thing that you need to know when it comes to aviation, right? When it comes to aviation, there is this thing called ICAO standard atmosphere, right? ICAO standard atmosphere. ICAO කියන්නේ International Civil Aviation Organization, right? International Civil Aviation Organization. The short form of that is ICAO. Then ICAO standard atmosphere or ISA. This is called the ISA atmosphere. This is a standard atmosphere. There are instruments in the aircraft that rely on this density, pressure, temperature to give you the readings that you need, airspeed, altitude, or whatever, right? And to give you those readings, these instruments need to be calibrated. They need to start from a particular point, right? And this particular point is the standard atmosphere, right? This is a set of defined properties, right? These defined properties are like this, right? At the mean sea level, this is the defined modula. මේව ඇත්තටම කොහෙවත් තියනවා කියලා නෙමෙයි කියන්නේ. These conditions are not there in any place. These are just the defined quantities, right? So in the standard atmosphere conditions, the sea level temperature, මුහුදු මට්ටමේ තියෙන උෂ්ණත්වය සෙල්සියස් අංශක 15යි 15 සෙල්සියස් කියලා කියනවා, right? Pressure එක 1013.25 hectopascals. Unit එක ගැන වැඩි හිතන්න එපා. Density 1.225 kilograms per cubic meter, right? So if you plan on having a career as a pilot, as a pilot or an engineer, this is something that's there in your absolute basic level, right? එහෙම ඉන්න කෙනෙක් ඉන්නවා නම් මේවා පොඩ්ඩක් දැම්ම ලියාගෙන තියාගත්තත් ප්‍රශ්නයක් නැහැ. This is absolutely necessary if you are going there, right? And I told you temperature is decreasing with altitude, so you can see temperature decreases by 1.98 Celsius per 1000 feet, or we can just round it off to 2 Celsius. So every 1000 feet you go up, your temperature decreases by 2 Celsius, right? අඩි 1000ක් උඩට ගියොත් ඔයාගේ temperature එක Celsius අංශක දෙකකින් අඩු වෙනවා. If your surface temperature, let's say Colombo, right? Colombo, let's say the surface temperature is 30 Celsius, which is a common temperature for Colombo area, right? So if you go 1000, if you get on a helicopter and go 1000 feet above Colombo, you're not feeling 30, you're feeling 28, right? That's 1000 feet. If you go 2000, you're feeling 26. Likewise, for every 1000 feet, your temperature is reducing, right? By 2 Celsius. ඔන්න ඕක හින්දා තමයි නෝරේලියා පොඩ්ඩක් සීතල. ඒගොල්ලෝ ඉන්න ගොඩක් උඩ කොහොම දෙක අඩු වෙලා ගිහිල්ලා ඒගොල්ලෝ ඉවර වෙන්නේ කොහෙද? නිකන් 14 15 16. ඔන්න ඔය වගේ ගණන් වල, right? So is that clear? So that's there are more stuff if you want to learn. There are more stuff about the atmosphere, right? You can look them up and learn, right? I'm not going to take more time there. I actually took more time than I expected for this unit, right? So if you have any questions, you can ask. If not, I'm just going to go to the today's actual part, the 4 forces in flight, the fundamentals in flight. Any questions here? Any questions? Okay, I take the silence as a sign that everyone got what I said. I'm happy if that happened, right? Okay. All right.
Having examined the problem, we can...
Right. So when it comes to flight, right? When it comes to an aircraft, this applies even in a normal car, right? There are 2 types of pressures that we are talking about, right? So one pressure we have already defined what it is. That's the atmospheric pressure. That's where we are starting. Even you right now are experiencing atmospheric pressure, you and I both, right? Without atmospheric pressure, we can't live, we will die, right? And but we are all accustomed to it. We have a certain pressure on us, but we are accustomed to it, so we don't feel it, right? That's what we call atmospheric pressure, right? So that's there, that we have already said what it is, right? Then there is something called dynamic pressure. Then there is something called dynamic pressure. Has anyone here, this is not something that I usually recommend, but has this is okay if you're doing a highway, right? Has anyone here put their hand out, right? Don't put like that, right? Don't put it all the way out. But is there anyone here who has put their hands out while they are going fast in a vehicle?
I have in a normal road.
I have enough.
Normal road, not in a highway.
No, it doesn't have to be on a highway. Whatever road, I just said that it's better on a highway because in a normal road, you know, there are vehicles going here and there all the time. Anyways, doesn't matter what road you are doing it, but if you have put your hand out, right? If you have put your hand out, what do you feel? Someone who has put their hand out, tell me what you feel.
It feels like the air is pushing you the opposite direction you are going.
Very good. AI is pushing you in the opposite direction to whatever the direction that you're moving, right? That pressure that you feel on your hand is dynamic pressure, right? So you have the atmospheric pressure, the pressure that's already there, right? That it's already there, nothing you can do about that. And then you have the dynamic pressure. Dynamic pressure is when something is moving through this air, right? When an object is moving through air, and then you get a pressure on it, right? So this pressure is called the dynamic pressure. If you take atmospheric pressure acts in all directions, right? Atmospheric pressure acts in all directions, right? If you take this box here, atmospheric pressure would be acting on all directions like this, right? But if you are moving, let's say this box is being moved, right? You are moving this box in this direction, then you are going to feel a force, right? Then you are going to feel a force in the opposite direction, right? This one is called the dynamic pressure. This is only there if you are moving and it acts opposite to whatever the direction that you are moving, right? So you have this is called the atmospheric pressure, or in principles of flight we call it static pressure, because it's not something that's going and coming, it's always there. We call it static pressure, right? And this is the dynamic pressure. Dynamic is you are moving, when you're changing, this happens, right? This is something very changeable. So this is called static, and this is called dynamic, right? So when you are moving, you are feeling both these pressures, right? When you are moving, you feel both these pressures. So the addition of these two is called the total pressure, right? Total pressure. So this is what an aircraft feels, right? This is what an aircraft feels. Not only an aircraft, any vehicle, any object, even you, when you are moving through air, you feel total pressure, right? So that's what we are starting with. And this dynamic pressure can be too high to a point. If you see hurricanes, tornadoes, or stuff like that, those are very good examples of how forceful or how powerful this dynamic pressure can be, right? So these pressures only lift this aircraft up, lift this aircraft up. The pieces of metal with people and stuff that are in it, weighing over 100 tons, are getting lifted in air because of the behavior of these forces. So you can think air pressure, nothing much, air can't do much, I don't feel air, right? But it's a very powerful force if you can use it the correct way, right? So you can lift things up that are like over 100 tons in weight, right? So just by manipulating these forces. Any questions about this static dynamic pressures? No? Okay.
Be in no doubt upon hearing the thud of the
Right. So if you move air mass of 1 kilogram, right, then it will have the same effect. Okay, let's say let's take it like this. I have a brick that weighs 1 kilogram, right? මං ගාව ගඩොලක් තියෙනවා ඒ ගඩොලක් කිලෝවක් වඩයි. මං ඒ ගඩොලෙන් කාට හරි ගහනවා. මොකද වෙන්නේ? ඒ ගඩොල ගිහිලා වදිනවා ඒ මනුස්සයාට එක්ක තුවාල වෙයි මොන හරි දෙයක් වෙයි. Right? Now I have 1 kilogram of air. Right? Now I have 1 kilogram of air. Right? So what will happen if I throw this air parcel at somebody or at something? Right? ගඩොල ගැහුවොත් නම් ගඩොල ගිහිලා රදුනා තුවාල වුණා ඩැමේජ් එකක් වුණා මොන හරි එකක් වුණා ඉවරයි. air parcel එකකට මොකද වෙන්නේ? air parcel එකක් ගිහිලා ගැහුවොත්
They move around something.
Very good. Right, the brick cannot move around. It's a solid, right? It cannot like go around the thing or whatever, right? So it hits that, does some damage, falls down. What about air? Air also hits the object, but that force is more spread out, right? That force is more spread out, so you don't feel it. But did you feel any less force? No, right? You felt the same 1 kilogram force, but it was just distributed around a certain surface. That's why you didn't feel it much, right? If I throw a brick at you, there is nothing to spread. Where the brick touches your head or wherever, you are going to get 1 kilogram at that particular point, so you get damage. If I throw air also, if it was solid, it will do the same damage as the brick, right? But it's not solid. It moves around, distributing that force evenly, so you don't feel that force. That's why it's hard to think that air has force, right? Because it spreads out nicely. But if you throw it at the right speed, even air is enough to cut your hands off, right? So you might not have sometimes seen there are air cutters or water cutters. By just using the pressure of the air or water alone, you can cut things off, like metal, anything, you name it, you can cut it, right? So that's how the pressure behaves. And there's an equation here. You don't have to know anything about equations. All you have to know is the amount of this pressure depends on the speed of the movement, right? කොච්චර හයියෙන් යනවද ඒ ස්පීඩ් එක අනුව තමයි මේ ප්‍රෙෂර් එක කොච්චරද කියලා ඩිපෙන්ඩ් වෙන්නේ සහ density, right? The density and air. Higher the density, higher the dynamic pressure. Higher the velocity, higher the dynamic pressure again, right? So if you have more dense air, more dynamic pressure. If you have more velocity, more dynamic pressure again, right? That's all you need to know. There's an equation here. If there's anyone like who is interested, you can actually note it down or whatever, but at this stage kind of too complex for you all. If you want, I don't mind, but all you need to know at this stage is higher the density, more dynamic pressure, higher the speed, more dynamic pressure.
This pressure energy is called dynamic pressure, and the symbol you
Right, so this is the force around an aircraft, right? We have the total pressure acting on all directions, and then dynamic pressure acting on just one direction.
when a body
Right.
like a
And there's this thing called relative airflow.
total
Relative airflow is I won't explain what it is right now, right? What that means is the velocity and the direction of the airflow relative to you, right? This is relative motion, which is A-level maths physics stuff, so I won't talk about that a lot here, right? But what that means is the relative motion of air and the air relative to the body of the aircraft and its speed, right? So the dynamic pressure depends on that. That's what they meant there, right? And then there is this thing called boundary layer and friction, right? Boundary layer is the first few millimeters. If you take the aircraft surface, let's say this is the aircraft surface, right? When air is moving like this, the first few millimeters on top of the surface is where the boundary layer is, right? This is also a bit of a more advanced topic. I won't spend much time there, right? All you need to remember is, all you need to know is this boundary layer can be two types, right? You can have laminar flow, right? That's the clean, nice flow. And then you can have turbulent flow, right? Laminar flow, turbulent flow. Laminar flow, what's on the board is laminar flow. What's on the screen is laminar flow, right? So it's very nice, clean, nice straight lines without going here and there. Very obedient, nice people, nice air, right? This is what we need. But sometimes this can be turbulent, like this, right? This is what we call turbulent airflow. They have no direction, they have no purpose, right? This is bad, this is good. That's basically it, right? For an aircraft, this is good, this is bad, right? So this is what we try to achieve in an aircraft all the time. This is what we try to avoid.
Turbulent flow.
Anyways, so this is the laminar flow, right? It goes so this shape is called an aerofoil. This is what produces the lift. How that happens, I'll let you know in a while. But this is the laminar flow.
This time,
And in the laminar flow, you can see here you have more gaps between the lines. Here you have less gaps between the lines. So what this means is, if you have lower gaps, if you have smaller gaps, the air is moving faster, right? The air is moving faster. Here air is moving slower. Now keep that in mind. That will be useful, right? So where is air flowing faster? On top of the ring, right? Where is air flowing slower? In other areas, right? On the top of the surface, air is moving faster. මතක තියාගෙන ඉන්න ඉස්සරහට ඕන වෙයි.
this type of flow is shown
This can
graphically.
later become turbulent in certain conditions. I won't go into those details. Right.
One of the
Plane ඉස්සෙල්ලාම ප්‍රශ්නයක් අහුවා plane එකක් උඩ යන්නේ කොහොමද කියලා, right? So the answer to that question came in the terms of, okay, you have wings produce lift, right? And then there is a bit of a more advanced answer. There is a pressure difference, and then this pressure difference is what gives you this lifting force, right? So I'm going to explain to you now how this pressure difference occurred in the first place, right? So I'm just going to explain to you how this pressure difference occurred in the first place, right? So before we learn about that, we need to learn about two things, right? Both these things are like A-level maths, A-level physics stuff, but without this you can't understand how the aircraft flies up, right? So I'll try my best to explain this in the simplest form as I can, right? So these two are continuity equation and Bernoulli's theorem, right? ඔය දෙකට කියනවා continuity equation සහ Bernoulli's theorem, right? I'll first go through the continuity equation and then go to the Bernoulli's theorem, right? So continuity equation is what we do first, and then on that, on the result of that, we'll go to the Bernoulli's theorem, right? Okay. So first, the continuity equation. So here you can see a tube, right? There is a tube here, right? To explain this better, I'll just use paint. It's easier for me, right? Let's say there is a tube, right? Again, I'm drawing from a mouse, so drawings could be bad. I'll take a tube like this. This tube has a certain area on one end, and this tube has a smaller area on the other end, right? So this is the tube. Now from the shape of the tube, you can see the area here. I'll call it A1, right? A1 is here. This is the area, the cross-sectional area. This is A2, cross-sectional area 2, right? එතකොට මේක දැක්කහම අපිට මොකද්ද තේරෙන්නේ, right? මේක දිහා බලලා අපිට කියන්න පුළුවන් A1 කියන එක ලොකුයි A2 වලට වඩා කියලා, right? You can see this end is bigger. This end has a bigger area than this end, right? Okay, so we keep it as that. Continuity equation says, right? Continuity equation says when you are considering a flow through a tube, right? Area into velocity is constant, right? Now මේක අස්සෙන් air flow එකක් කියවුවා, right? If you send an air flow through this tube like this, right? So මෙන්න මේ air flow එකේ area into velocity, right? මෙතන මේ area එක speed එකෙන් වැඩි කරාම එන උත්තරේ constant කියලා කියනවා. ඒක වෙනස් වෙන්නේ නැහැ කියලා කියනවා. එකමයි කියලා කියනවා, right? එතකොට මේක මෙහෙම වුණා කියලා කියන්නේ, right? මෙතන මේ area එකක් තියෙනවා. මෙතන එතනින් ඇතුළට යන velocity එකක් තියෙනවා, right? අපි මේ velocity නැත්නම් speed එකට කියමු v1 කියලා. v1, right? මේක තේරෙන්නේ නැති කවුරු හරි ඉන්නවා නම් අහන්න කියලා දෙන්නම්, right? මේකට කියනවා v2 කියලා. right? මෙතනින් ඇතුළට යන ස්පීඩ් එකට අපි කියනවා v1 කියලා. මෙතනින් එළියට එන ස්පීඩ් එකට කියනවා v2 කියලා, right? What the equation of continuity says is the multiplication of these two is constant, right? ඒ කියන්නේ මේ දෙන්න වැඩි කරාම එන උත්තරේ මෙතනත් එකයි මෙතනත් එකයි, right? ඒ කියන්නේ A1 වැඩි කිරීම B1 කියන දේ සමානයි A2 වැඩි කිරීම B2 කියන එක. right? මේ දෙන්න සමානයි කියලා කියනවා. right? මේ මෙයා කියන්නේ මෙන්න මේක කියන meaning එක තමයි මේ තියෙන්නේ. right? හැබැයි මෙන්න මේ diagram එක දිහා බලුවම ඔයාලට පේනවා A1 කියන එක ලොකුයි A2 කියන එකට වඩා. A1 එක ලොකුයි A2 කියන එකට වඩා. right? හැබැයි මෙන්න මෙයා කියනවා මෙන්න මේ multiplication එකත් සමානයි කියලා. right? ඕක වෙන්න පුළුවන් එකම විදිහයි තියෙන්නේ. right? ඕක වෙන්න පුළුවන් එකම විදිහයි තියෙන්නේ. මේක කියන්නේ A1 එක වැඩි A2 එක අඩුයි කියලා. right? දැන් මේක මේ equal sign එක මෙතනට දාන්න පුළුවන් එකම condition එකයි තියෙන්නේ. ඒ condition එක තමයි මෙන්න මේ speed එක එහෙනම් මෙතන අඩු වෙන්න ඕනේ. මෙතන speed එක වැඩි වෙන්න ඕනේ. right? මෙතන මේ A1 එකත් එක්ක තියෙන speed එක අඩු වෙන්න ඕනේ මොකද A1 වැඩි හින්දා. A2 එකත් එක්ක තියෙන speed එක වැඩි වෙන්න ඕනේ මොකද A2 අඩු හින්දා. right? ඔන්න ඕක තමයි equation of continuity කියලා කියන්නේ. එතකොට මෙතන මොකද්ද වෙන්නේ? මෙතන වෙන්නේ V2 කියන එක sorry V1 කියන එක අඩුයි V2 එකට වඩා. වෙන විදිහකට කියනවා නම් if I say in other terms this airflow comes out faster from this end than you put in here, right? So there is a very practical application to this. If you have ever used a hose to water your plants, right? If you have ever used a hose, okay, to this question I will answer later, right, after the session. There's a question about engineering and piloting courses. I'll answer that at the end of the session, right? So on to this, this is something that you would see in your day-to-day life as well, right? If you use a hose to plant your water, to water your plants, right? Then you would have noticed this. If you want the water to go further, if you want the water to come out faster, what do you do? ඔයගොල්ලෝ හෝස් එකක් අරගෙන මල් පැලයට මොනවාට හරි වතුර දානවා නම් අර නිකන් පොඩ්ඩක් දුර තියෙන මල් පැලයකට වතුර දාන්න මොකද කරන්නේ?
We increase the diameter.
We squeeze the end of the hose and reduce the area. Sorry, I didn't hear the last part.
Pressurize it.
Yeah, pressurize it is a different option that you need a motor or whatever, right? But at the moment, නිකන් වතුර දදා ඉන්න ගම පොඩ්ඩක් එහා පැත්තේ කඩේට දාන්න ඕන නම් මොකද කරන්නේ? චුට්ටක් හෝස් එකේ අන්තිම චුට්ටක් මිරිකනවානේ. ඒක එක්ක මිරිකනවා පොඩ්ඩක් නැත්නම් මෙහෙම අල්ලනවා. right? මොකක්ද ඒ කරන්නේ? මෙන්න මෙතන ඒරියා එක අඩු කරන එක තමයි කරන්නේ. ඒරියා එක අඩු කරාම මොකද වෙන්නේ? වතුර පාර හයියෙන් එනවා. හයියෙන් එනවා කියන්නේ ඒක වැඩිපුර දුර යනවා. ඔන්න ඔක තමයි උතන වෙන්නේ. right? Did you understand this? Did everyone understand this? We need this to talk about the Bernoulli's theorem. මේක මෙතනින් තේරුම් නැති කවුරු හරි ඉන්නවනම් කියන්න. Okay. ජිහාන්. ජිහාන් මල්ලි මේක වෙන්නේ මෙහෙමයි. right? ඔයා ටියුබ් එකක් ගත්තොත් මේ ටියුබ් එකේ වට ජිහාන් ඉන්නවද මෙතන ඉන්නවා. right? මල්ලි මට උත්තර දෙන්න වට තේරෙනවා නම් right? මෙතන අපි මේ ටියුබ් එකේ මේ පැත්ත ලොකුයි මේ පැත්තට වඩා. ඒක පේනවද වට? right? මම යා මොනවාරි කිව්වා මම හිතන්නේ ඇහුන්නේ නැහැ. හරි. නැත්නම් කියන්න. right? හරි. අපි දැන් මෙතනින් මොන හරි යවනවා. right? අපි කියමු මෙතනින් වතුර යවන්න පුළුවන්. එහෙම නැත්නම් මෙතනින් හුලං යවන්න පුළුවන්. ඔයා හිතන්නවා මේ පැත්තට කට තියෙන මේකෙන් තිබිනවා. right? okay. then what happens? එතකොට මොකද වෙන්නේ? මෙතනින් මේ යන හුලං පාර right? නැත්නම් වතුර කියන්න පුළුවන්. වතුරට උත්තර ඕකම තමයි වෙන්නේ. මෙතනින් කොච්චරක් ඇතුළට යනවද එකපාරක් ඒ ටික ඔක්කොම මේ පැත්තෙන් එළියට එන්නත් ඕනේ එකම වෙලාවට. right? මෙතනින් ඔය ඇතුළට දාන ටික මෙතනින් එළියට එන්නත් ඕනේ. right? හැබැයි මෙතනට ගොඩක් ඉඩ තියෙනවා ඇතුළට යන්න. right? මෙතනට ගොඩක් ඉඩ තියෙනවා ඇතුළට යන්න. මෙතන ඉඩ තියෙන චුට්ටයි. right? ඉතින් මොකද වෙන්නේ? ඔයා මෙතනින් හිතන්න අපි වතුර කිලෝවක් දැම්ම ඇතුළට. එහෙම නැත්නම් වතුර ලීටරයක් දැම්ම ඇතුළට. ඔය වතුර ලීටරේ ගියේ ලොකු ඒරියා එකකින්. එතකොට යාට එච්චර හයියෙන් යන්න ඕනේ නැහැ. right? යාට එච්චර හයියෙන් යන්න ඕනේ නැහැ. අපි මෙතනට වතුර ලීටරයක් දැම්ම එක තත්පරයකට යා එතනින් ඇතුළට ගියා. යාට ගොඩක් හයියෙන් යන්න උවමනාවක් නැහැ. මොකද යාට ලොකු ඒරියා එකක් තියෙනවා. හැබැයි මෙතනදී මොකද වෙන්නේ? දැන් ඔය මෙතනින් වතුර ලීටරයක් අපි ඇතුළට දැම්මා. ඔය වතුර ලීටරේම අපව මෙතනින් එළියට එන්නත් ඕනේ. එතකොට මොකද වෙන්නේ? මෙයා තත්පරයකින් වතුර ලීටරය ඇතුළට දැම්මා. මෙයාගෙන් තත්පරයකින් එළියට එන්න ඕනේ. මෙයාට එක තත්පරයකින් එළියට දාන්න කරන්න තියෙන එකම දේ තමයි හයියෙන් එළියට එන්න. මෙතන ආපු ස්පීඩ් එකට වඩා හයියෙන් එළියට එන එක. right? ඕක තේරුම් නැත්නම් මෙන්න මේක මෙහෙම මතක තියාගන්න. right? මේක මතක තියාගන්න ඒරියා එක වැඩි තැනින් හුලම් පාර හරි වතුර පාර හරි මොන හරි එක යන්නේ හිමීට. right? මෙන්න මේ මෙතන ඇතුළට යන ඉන්ෆ්ලෝ එක යන්නේ හිමීට. මෙතනින් එළියට එන එක ගොඩක් හයියෙන් එළියට එනවා. ඒක තේරුණාද? එහෙනම් ඒක ආවගේ මයික් එක වැඩ කරන්නේ නැහැ. හරි කමක් නැහැ. ඔයාලට ඒක ටෙක්ස්ට් එකක් දාන්න පුළුවන් chat box එකේ. තේරුණාද නැද්ද ඒක? right. මම හිතනවා තේරුණා කියලා. තේරුණ නැත්නම් පොඩි ටෙක්ස්ට් එකක් දාලා තියන්න මම එක්ස්ප්ලেইন කරන්න ආපහු පස්සේ. හරිද? හරි. තේරුණා. හොඳයි. right? ඒක තේරුණා නම් අපිට දැන් යන්න පුළුවන් බර්න්වලිස් තියරම් එකට. right? දැන් යන්න පුළුවන් බර්න්වලිස් තියරම් එකට. බර්න්වලිස් තියරම් එකෙන් කියන්නේ මොකද්ද? බර්න්වලිස් තියරම් එකෙන් කියන්නේ මොකද්ද? දැන් මෙයා equation of continuity එකෙන් කිව්වා මෙයාගේ තියෙන area into velocity relationship එක ගැන. බර්න්වලිස් තියරම් එක කියන මේකට අපි කියන්නේ mass flow කියලා. mass flow එක constant. ඒක තමයි අපි කියන්නේ. right? බර්න්වලිස් තියරම් එක කියන්නේ මෙන්න මේ flow එකේ තියෙන energy එක constant කියලා. right? මේ flow එකේ තියෙන energy එක constant කියලා කියනවා. right? ඒක අපි කියනවා මෙන්න මේ විදිහට. මේකේ terms ගැන වැඩි හිතන්න යන්න එපා. right? Bernoulli's theorem in simple terms කියන්නේ මෙන්න මේක. right? Potential energy එහෙම නැත්නම් මේකට pressure energy කිව්වත් කමක් නැහැ. pressure energy කියලා ගමු වැඩි ලේසි. right? pressure energy plus kinetic energy equals constant. pressure energy කියලා කියන්නේ මෙන්න මෙතන තියෙන pressure එක හින්දා අපිට හම්බ වෙන energy එක. kinetic energy කියලා කියන්නේ මෙන්න මෙතන තියෙන movement එක. එයාගේ speed එකක් තියෙනවා කියලා කිව්වා. මෙන්න මේ speed එකත් එක්ක අපිට හම්බ වෙන velocity එක එන energy එක තමයි kinetic energy කියලා කියන්නේ. right? සමහරට මේ grade 6 7 ඉන්න මල්ලිලාට මේ terms එච්චර තේරෙන එකක් නැහැ. වැඩි ගණන් ගන්න එපා. right? මම කියලා දෙන්න ලැබුණාම ඔයාලට තේරි හරියට මොකද උනේ කියලා. right? මෙතනින් කියන්නේ මේ මෙන්න මෙතන තියෙන pressure එකයි එතකොට kinetic energy එක මෙතන මෙහෙම හිතන්න මෙතන තියෙන pressure එකයි speed එකයි එකතු කරාම වෙන ගාන. The sum of pressure and the speed here. Those who don't understand these two can think of it like that. The sum of pressure and speed here is equal to the sum of pressure and speed here. Right? මෙතන තියෙන එකට අපි මම කියනවා P1 කියලා. The pressure I'll say P1. Right? And here pressure I'll say P2. Right? එතකොට Bernoulli's theorem එකේ කියන්නේ P1 plus V1 equals P2 plus V2. right? දැන් ඔයගොල්ලෝ කොහෙවත් ගිහිල්ලා කියන්න එපා pressure එකයි velocity එකයි එකතු කරාම ඒක සමානයි කියලා. එහෙම නෙමෙයි වෙන්නේ. right? මේකේ energies දෙක තමයි සමාන වෙන්නේ. ඔයගොල්ලන්ට තේරෙන්න ලේසියෙන් තමයි මම pressure එකයි speed එකයි කියලා කිව්වේ. right? එතකොට මෙයා කියන්නේ මොකද්ද? මෙතන තියෙන pressure එකයි මෙතන තියෙන ස්පීඩ් එකයි එකතු කරාම එන ගාන සමානයි මෙන්න මෙතන තියෙන ප්‍රෙෂර් එකයි මෙතන තියෙන ස්පීඩ් එකයි එකතු කරාම එන ගාන right අපේ මේ ප්‍රෙෂර් එනර්ජි කයිනටික් එනර්ජි කියන එක තේරෙන්නේ නැති කට්ටිය මේ විදිහට හිතා ගන්න right හරියම එක තමයි මේක මම නිකන් ඔයගොල්ලන්ට කියලා දෙන්න දැනට කියන දෙයක් right හරි හැබැයි අපි equation of continuity එකකින් දන්නවා right equation of continuity එකෙන් දන්නවා මෙන්න මේක right මොකද්ද මේ කියලා තියෙන්නේ V1 is smaller than V2 right V1 is smaller than V2 V1 එක අඩුයි V2 එක වැඩි මෙතනටත් මම මේ කේස් එකම තමයි මෙයා අඩුයි මෙයා වැඩි නම් මේ දෙන්න සමාන වෙලා ඉන්න පුළුවන් එකම ඔප්ෂන් එක තමයි මෙතන එහෙනම් ප්‍රෙෂර් එක වැඩි වෙන්න ඕනේ මෙතන ප්‍රෙෂර් එක අඩු වෙන්න ඕනේ right මොන ප්‍රෙෂර් එකද මේ අපි ඉස්සෙල්ලා ප්‍රෙෂර්ස් දාපු දෙකක් ගැන කිව්වා ඩයිනමික් ප්‍රෙෂර් කිව්වා ස්ටැටික් ප්‍රෙෂර් කිව්වා මොන ප්‍රෙෂර් එකද මේ අඩු වැඩි වෙන්නේ මෙතන
static pressure
very good static pressure right so I told you dynamic pressure is something that comes with the speed so what's happening here dynamic pressure is increasing static pressure is increasing dynamic pressure is decreasing static pressure is decreasing ඔන්නගේ ඉස්සෙල්ලා කිව්ව එකට දැන් වෙන්නේ ඉස්සෙල්ලා මොකද්ද කිව්වේ dynamic plus static equals total pressure කියලා කිව්වා දැන් මෙයා මොකද්ද කියන්නේ මේ බර්නෝලිස් තියරම් කියන්නේ මොකද්ද total pressure is constant right so for that to happen whenever the dynamic pressure is increasing the static will decrease right whenever the dynamic pressure is increasing the static pressure is decreasing right the faster you are going the higher the dynamic pressure is and if this airflow is going through an area like this if this airflow is forced through an area like this through a small area මොකද වෙන්නේ pressure එක අඩු වෙනවා මොන pressure එකද අඩු වෙන්නේ static pressure එක dynamic pressure වැඩි වෙනවා static pressure එක අඩු වෙනවා right ඔන්න ඕක තමයි වෙන්නේ right now let's come back to the diagram of this unity
Consider a streamlined flow of air passing through a tube. This
right එතකොට මේ මම නම් ගත්ත මෙන්න මේ වගේ diagram එකක් මේ CBT එක පෙන්නන්නේ මේ වගේ diagram එකකින් කොහොම හරි area එක අඩු වෙනවා නම් ඉච්චරයි වෙන්නේ
Let's now consider
මෙන්න මේ වගේ right
the airflow will
මෙතනදී airflow එක හිමීට යන්නේ මෙතනදී high එකෙන්
increase in velocity.
animation එකක් බලන්න right මෙතන restriction එකෙන් යද්දී එක high එකෙන් යනවා right අපි මේ tube එක කොහොමද aircraft එකට apply වෙන්නේ අපි දැන් මේ කිව්වේ tube එකක් ගැන
aerofoil
very good right the aerofoil right the aerofoil has a shape like this කට්ටිය දන්නවනේ ටික right so the aerofoil has a particular shape right an aerofoil is a shape like this it has a flat bottom right මම අද දුකන මෙච්චරම flat නෑ but yeah anyways right it has a flat bottom and a curved top surface right I think it's better on this whiteboard right it has a flat bottom and a curved top section let me get this correct okay this is a very ugly aerofoil don't mind the ugliness yeah anyways I'm going on a mouse right so this is an aerofoil shape right this is roughly an aerofoil shape it has a flat bottom and a curved top section right earlier I said something about a relative airflow right so this airflow is just flowing past this right so there's this boundary layer right so boundary layer is only a few millimeters thick and there's this airflow passing above it right what happens to the air molecules or the air that goes in between these two layers, right? So here you can see what's happening here, right? So here, what's happening here? You have this area here. You have a higher area here. See, you have a higher area here, right? What's happening here? There is a small area here, right? Right? So we have a smaller area here, right? Higher area, small area. So what happens when the air is flowing through this small area, right? The speed of the airflow increases, right? So because of the speed of the aircraft, you already have a speed, let's say 100 kilometers per hour, right? 100 here, right? What happens here? It can increase, let's say, up to 130. I mean, you can numbers done, right? Numbers, so numbers, right? So these are the speeds, right? So here there is a increase in velocity or increase in dynamic pressure here. So what did we say happens with an increase in dynamic pressure? Anyone? When the dynamic pressure increases, what happens to the static pressure?
It decreases.
Static pressure decreases, right? So there is a low pressure area created here now, right? Here the pressure is decreasing. Now you have a low pressure area. So this area is a low pressure, right? Now මෙතන පල්ලෙහාට එහෙම ප්‍රශ්නයක් තියෙනවද? Do we have any problems here? On the bottom there is no curved surface, so the airflow more or less flows freely through this, right? So there is no pressure decrease here, right? එතකොට මොකද වෙන්නේ? මෙතන low pressure නම් මෙතනට මොකද වෙන්නේ? මෙතන high pressure වෙනවා. If this area is low pressure, relative to that, this becomes a high pressure. So what happens from high to low? What happens if there is a high pressure and a low pressure?
The air molecules start to balance the pressure.
Right. They want to balance the pressure, right? They don't like to stay like this. They don't like to stay high and low. They all want to stay the same level, right? So what happens? The air molecules here, it won't be completely balanced only, right? If it's balancing, then there is no pressure difference. You can't fly, right? So what happens is to balance this out, they are trying to go to the low pressure, right? They are trying to go to the low pressure, but can they go to the low pressure?
No.
Why not?
Because it's like covered by the wing.
Very good. It's covered by the wing, right? So what happens? There is this air molecules, right? The air molecules are here. All these air molecules are just trying to go there, but they can't. They are just pushing on the wing. Poor air molecules, they are just pushing on the wing like this, right? So when you are getting pushed like this, it creates a force, right? It creates a force. That force is going up like this. What do we call this force?
Lift.
Lift. So this is what we call lift, right? So this is how the lift in an aircraft is generated. Any questions? So this is answering my first question. How an aircraft is flying. This is how, right? This is how it stays airborne, right? So what's giving this airflow?
The engines helping it to go.
Right, the engines are generating the thrust, right? The engines are generating the thrust. So this is the lift. Then there is engine. I have only drawn the wing here. In the aircraft somewhere there is an engine. This engine is pushing you forward or pulling you forward, right? This engine is engine එක ආව ඇදගෙන ඉස්සරහට යනවා. මේ ඉස්සරහට යනකොට මොකද වෙන්නේ? ඔයාට ඇවිල්ලා වදිනවා හොඳ හුලම් පාරක්. ඔන්න ඔය හුලම් පාර හින්දා මෙන්න මේ වගේ දෙයක් වෙනවා. right? ඕක තමයි මොකද්ද? engines වලින් දෙන මේ force එකට තමයි අපි කියන්නේ thrust එක කියලා. right? Right. තව forces දෙකක් තියෙනවා. මොනවාද? What are the remaining forces? Drag and weight, right? So what is aircraft? What are the how an aircraft is made? You have all the metals, the wing is there, the landing gear, engines, and you have the passengers or the pilots inside, right? all of them, they have a weight. They are made of matter, right? They have a mass. And what happens when this mass is in the gravity? Making plane එකක් වෙන්න ඕනේ නැහැ. ඕගොල්ලන්ටත් එච්චර තමයි, right? ඔයාලගේ ඇඟේ matter mass කියන දේ තියෙනවා. ඕක වින්නකොට මොකද වෙන්නේ? Earth's gravity is there, and the Earth's gravity is pulling you down. So you have weight. That's how you are staying on here, no? Otherwise you will just keep on floating, right? Then you don't need lift, right, to fly if gravity was not there, right? So gravity is pulling you down. So whether you are in air or not, it doesn't matter. It just keeps on pulling you down. So I'll take a different color for that. Okay, there you have the weight, right? Without a drag එක කොහෙන්ද එන්නේ? So all these three forces, you know how they were generated now. Where is this drag coming from?
From the friction.
Good, right? So from the friction, these air molecules and the aircraft has friction between these surfaces, right? So this is actually a bit more advanced, right? Drag of the aircraft can be divided like this. You have the drag, we call this the total drag, right? We call this the total drag. Total drag can be divided into two induced drag and parasite drag, right? මෙන්න මේ විදිහට අපිට කැලි දෙකකට මේක බෙදන්න පුළුවන්, induced drag, parasite drag කියලා, right? So ඔයා කිව්ව friction කියන එක එන්නේ මෙන්න මේ parasite drag කියන කොටට, right? Friction is a part of parasite drag, right? So induced drag is caused because of the lift production, right? ඒක ටිකක් advanced වැඩි. Wingtip vortices කියලා දෙයක් සමහර විට ඔයගොල්ලෝ අහලා ඇති. Have you seen when an aircraft is flying through a cloud? It doesn't have to fly through a cloud. If the density conditions are just right, you see two tiny tornadoes coming out of the aircraft wingtips. Have you ever seen things like that?
I saw it in the YouTube.
Right. So you have seen in the YouTube. Let me show one here for the ones who have not seen. මේ තියෙන අර ඉස්සලා කිව්ව විදිය low pressure එක උඩ high pressure එක උඩ. ඔය high pressure එක මෙන්න මෙහෙම wing tip එකෙන් පොඩ්ඩක් පැන ගන්නවා උඩට. ඔන්න ඔය පයින්න ගිහිල්ලා තමයි wing tip vortex කියන දේ හැදෙන්නේ, right? So this high pressure tries to go up somehow. In this area you can't go because the wing is there, but from the wing tip it might be able to jump up a little bit. This is what's causing wing tip vortices. And ඒක පොඩ්ඩක් advanced වැඩි ඔයගොල්ලෝගේ level එකට මම නිකන් පෙන්නනවා මොන වගේද කියලා. See? This is what I'm talking about, right?
We can't see no.
Can't see? Wait.
Yes, you have shared the whiteboard, not the screen.
Yeah, sorry. Give me a second. I thought my entire screen was not shared. Okay, this one. See? These are the wingtip vortices.
So is that fuel leaking from that small strip?
No, that's not fuel. That's not fuel. That's water vapor. That's it's flying through some foggy, misty conditions.
Okay.
This one you can't see. See, this is not fuel or anything. This is not fuel or water or anything. This is just air. This is just air spiraling away. So wingtip vortices sometimes can come out of the flaps as well. These are the flaps of the aircraft, right? So these aircraft, they have this in these aircraft, in almost all commercial aircraft, you can see these wingtips designed like this, right? This is there to prevent this from happening because we don't want this happening, right? These wingtips are there to, these special wingtip designs are there to prevent this from happening. So wherever they have the space to do that, they can do that, right? So here the flaps are deployed, so the flaps don't have a guard like this. එහෙම guard එකක් නැහැ flaps වලට, right? ඒ එතනින් එයා එළියට පැනලා යනවා. ඒක තමයි මෙතන මේ fuel වත් වතුරවත් නෙමෙයි. This is just air, right? You can see air being condensed here. The water vapor in the air is being condensed here. වෙන්නේ කොහොමද? ඒවා එච්චර හිතන්න යන්න එපා. පොඩ්ඩක් complex mechanism එකක්. ඒක පේන විදිය complex mechanism එකක්. ඔබට තමයි විද්‍යුත් බෝඩිස් කියලා කියන්නේ. තියෙන ඒ වගේ තමයි. ලෑන්ඩ් කරපු ගමන් ඒක නැතුව යනවා. ඔගේ ප්‍රොප් ෆෝස් එකකුත් තියෙනවා. මේ ප්‍රොපෙල් එක වටේත් ඔය පේන්නේ පොඩි රැඩිලි හරි වගේ ඒ වගේ එකක් තමයි. ඒ ප්‍රොපෙල් එකෙන් එන වොෂ් එක.
Why do
Yeah,
you
complex.
don't want that happening? I mean that wind particle
Yeah.
thing.
Yeah.
Does
So
it cause drag?
because it causes drag, it causes more drag,
Okay.
right? So when you have that happening, right? When you have when you have that happening, right? This lift force here මේක එච්චර ටිකක් complex මේක වෙන්නේ කොහොමද කියන එක complex මම වෙන්නේ කොහොමද කියලා වෙන්නේ මොකද්ද කියලා කියන්නේ. When that happens, the lift force is, now earlier you had this much of lift. When that happens, the lift force decreases and tilts back, right? So earlier you had the lift like this. When that happens, lift reduces and tilts back, right? If the lift reduces, right, then the aircraft will go down, right? When the lift reduces, then the aircraft will go down, and then you have to lift this wing up, right? We call it angle of attack. You have to increase the angle of attack. You have to point the aircraft little bit up to prevent that from happening. When that happens, you will restore the lift, right? You will restore the lift, but since you are pointing it up, the lift again tilts back a little bit, right? So what happens here? Now the lift is not going straight up, it's going a little bit back as well. So this backward component of the lift is what we call induced drag, right? So this lift has two components now, one going back, one going up. If I were to resolve it like that, right? So there is a පොඩ්ඩක් පස්සට යන කැලලකුත් තියෙනවා, උඩට යන කැලලකුත් තියෙනවා. උඩට යන කැලලෙන් තමයි අපි උඩ ඉන්නේ. මේ පස්සට යන කැලලට මොකද වෙන්නේ? ඔන්න මේ පස්සට යන කැලලට තමයි මේ අපි induced drag කියලා කියන්නේ. Right? So this is what we call induced drag, right? So the other types of, so when this is the lift related drag, higher the lift you have, higher the induced drag you have, right? Parasite drag is the friction, right? Parasite drag is the friction and pressure drag, right? So you can think like that. So this is how the drag is generated, right? That's how the drag is generated. Any questions? Not a prashna තියෙනවද? These are the four fundamental forces. Any questions here?
I have a question on related to, I mean, like the whole lesson.
Okay.
Have you like actually driven a plane?
Yes, so I have completed my training. So yeah, I have about 193 or 95 flying hours.
Okay. So like you, like, are you going to be a pilot, or like?
We would like to ask that everyone kindly wait for a few minutes as we are experiencing some technical difficulties. Thank you.
Can everyone hear me?
Yes, I am.
Right. Um, as you can see, what I thought would happen happened. Okay, you can't see me either. Let's try increasing the brightness. No, yeah, won't work. So I'll just finish up what I was saying. Can I share the screen? Uh, I think you will need to make me. Okay, okay.
Yes, I think you should be able to.
Okay. So I was about to finish up anyways. Right. So I actually wanted to do a few more things, but since there's no power and also we are running out of time, that's what I wanted to cover is done, the fundamentals of flight. So that's what I was asked to do. So I think I covered the fundamental forces in the aircraft, right? So I'll be taking questions now. If you have any questions, I think there was one question being asked when I got disconnected. Can you just ask me that again if you don't mind?
Yeah.
Oh,
Yeah. So I asked you whether like you're hoping to be a real pilot, like piloting the Boeing 747 etc. planes.
yeah, that's the target. I have completed my licenses in the Cessna 152 and the multi-engine aircraft, the Seneca 2, Piper Seneca. So I'm planning
Okay.
to get there one day, hopefully with Sri Lanka, not Boeing's. So we at Sri Lankan Airlines we don't have Boeing, so hopefully
Yeah,
Airbuses.
yeah, boss. Okay, yeah, yeah. Okay.
Anything else? Wait, I think there was a question about training courses in the chat. So someone asked me about engineering courses and the PPL. For engineering, there are places that you can go to, but the options in this country as of right now are limited. Many options nahe. So if you want, you can look up on the Sri Lankan Aviation College or KDU, Kotalavan Defence University. So if you are into engineering. If you're into PPL, sorry, if you're into flying, I work in a flying training organization called the Lakwin Flight Academy. So you can certainly look us up. So if you're into that. So any other questions? Any other questions?
Yeah, do you need to like have like another and to like fight, like fly like a jet, like a fighter jet?
Sorry?
Like if you need like another more special license to like fly like a fighter plane or those fast planes?
It's like this only. So when you do a license, first you're starting with the PPL usually, right? So then you do the commercial license. So whatever the aircraft that you do those licenses on, you get the rating, right? So for an example, I did all my training in the Cessna 152. So I have the rating on the Cessna 152. I can fly that aircraft anytime I want, as long as my license and medicals are valid, right? And also I have the rating on the multi-engine aircraft, so that story applies to that as well. So if you want to fly, let's say, a different aircraft, right? Could be an aerobatic aircraft or could be anything else, right? Then I need to get another training on that aircraft and get that endorsement or rating on my license. So that's how it works. For any aircraft, even for fighters, I'm not sure about the fighters. The military procedures might be a bit different, right? So in Sri Lanka, if you want to be a fighter pilot, the only option is to join the Air Force, right? So you can't, if that's your thing, then don't do anything. I mean, there's no point doing the civilian training. In civilian training, you will never get to fly a fighter aircraft. So if that's your thing, you need to be in the Air Force and you need to be on the top performing field, right? So if you want to be a fighter pilot, you need to join the Air Force and you need to be one of the top performing guys there to be able to fly a fighter jet, right? They only take the top people.
Yeah.
Anything else?
No, yeah.
Okay, how does the lift get tilted in the first place? Lift, it's like this. So it's a bit of a complex mechanism, which is why I didn't explain the full thing, right? So whenever that wingtip vortice thing happens, right? Whenever that wingtip vortices are generated, then what happens is the amount of lift reduces and it tilts back, right? So I only said it tilts back because that mechanism is somewhat complex. But anyways, I'll just say what it is, right? Even without the wingtip vortices, the lift is a little tilted back, right? Even without the wingtip vortices, the lift is a little tilted back. That's what we call the total reaction. Again, I'm going into very complex scenarios here, right? That's what we call the total reaction. So it's slightly tilted back, right? So anyway, that's there to begin with, even without wingtip vortices. But with wingtip vortices, what happens is your overall lift reduces, right? Your overall lift reduces, and when the lift reduces, then you have to slightly point your nose up, right? This is not something that you do intentionally. When you're flying the aircraft, this automatically happens. You don't even feel it, right? So if you want to stay in the same level, you have to point the aircraft a little bit up, right? When you're pointing up, your wings are tilted back, right? When the aircraft is pointing up, you can try this with your hand. You can keep your hand flat and you can point your hand up, right? When you're pointing your hand up, you can see the flat surface on top of your hand tilts up. I could actually show this if I had power, if I had light around me, right? So that lifts up, right? So when that tilts back, the force of the lift is also tilting back. So there is a now backward component. That's how the tilting occurs in the simplest form that I can explain. The actual process is somewhat complex, so that's how it goes. Okay.
Excuse me, Aya.
Yeah.
So I've like seen some of the YouTube videos. They like show so when they land a big airplane like I mean a jet like the A320 or the A380, the big planes. So they always when they are just about to land, they tilt the nose up. What is the reason for that?
Because they don't want their nose hitting first. So you have in your landing undercarriages, right? In the landing gear, you have the ones that are in the back or in the center, not the back per se, that are in the center. That's the main wheel, right? So that's what's designed to take the full weight of the aircraft, right? Then you have just one wheel, right? You might have seen in almost all aircraft there is only one wheel at the front, or one bogie with either two wheels or four wheels or whatever. There is only one unit there, right? This unit can't take the weight of the aircraft, right? This unit can't
So it
take the
could
weight of the
collapse.
aircraft alone. Sorry.
So it could collapse if we just touch down
Yeah,
with
if you just touch down on the nose wheel, and if you put the weight of the aircraft on the nose wheel first without distributing it to the main wheels, it can collapse. It can be too heavy for the nose wheel. So that's why you come down, you keep your nose pointing down because you need to come down, right? And when you are doing that, at the maybe sometime before that or just before the landing, you point your nose up so your main wheels hit the ground first, not the nose wheel. So in a light aircraft like the Cessna, right until you come on top of the runway, your nose will be pointing down. Just before you are touching down, you will point your nose up. But in a big aircraft, you can't put the nose up just before you touch down. Those are very big. Those are heavy. They take some time to respond. So they come just from a certain distance. They come pointing their nose up already, and then they touch their main wheels first. That's the purpose.
Yeah.
Yeah.
So can you teach me the whole process of that? So the landing process of a A320 or some big airplane,
Process as in?
like how we should maintain the, what do you call it, the steering wheel like thing. So up and down. So I have experience. I mean, like I have experience of flight simulator, and I had actually a very terrifying experience. So when I was landing an A320, it was like I didn't know how to like land the plane. So in the instructions it said to take the nose up, but I didn't have the control. So the plane suddenly went down. It hit the ground with the first wheel, and like the plane tilted the whole way up. So
Okay,
like,
so yeah, that's why I said. That's what I said. In a big aircraft, because they are heavy, they take some time to respond, right? They take some time to respond. If you're in a 152 in a Cessna small aircraft, you can do you can actually do that. You can come pointing your nose down right until the end of the runway, and then you can lift it up. But in a big aircraft, in a heavy aircraft, that won't work because the aircraft takes some time to respond to that, right? So what usually happens is, since you are playing the flight sim, I think you might understand this. So you need to come at a slightly high altitude with a reduced power setting. Because the power is not there, you will start descending, right? So when you start as you are descending, you will be maintaining a slightly sub attitude.
Okay, so that means at what altitude should I start like tilting the nose up?
It depends from aircraft to aircraft. It depends. Usually from the point where you start, where you commence your final approach, that would be it. As in, like when you're in line with the runway, in the final leg, basically.
Like I have the A320, so that's why I'm asking lots of questions about it. Like
yeah, so yeah, you can do it if you are familiar with the term the short finals. So you can from short finals to that from that area that's fine. Yeah.
Excuse me, Aya.
Mm-hmm.
Like when you fly like a Cessna, they have the propeller in the middle.
Okay.
So like, how can you like see the front in like the front of the plane?
You don't see the propeller when it's running. It's turning that fast, so you don't really see the propeller. As in, like you can see the edge of the propeller, but you see right through it. As in, like that, it's not blocking your view. It's as if it's not there. It's that fast.
Okay.
excuse me, Aya, what is the normal cruising altitude?
For what aircraft?
I'm like obviously the A320. Like I have on that.
Jets it depends on the weight. So I think in the A320 you can go up to about 38,000 feet. But if you are heavy, then you can't go that high.
Alright, okay, yeah.
So it depends on the weight of the aircraft.
Okay,
Higher
thank
the
you.
weight, lower the altitude.
Okay, thank you. Yeah.
Anything else? Yeah, engineering. First thing, as I said, there are two options, two good options that you can. The two good options that you can select are the Sri Lankan Aviation College. They have the engineering. They have the maintenance course. So that's there. Aircraft maintenance. That is not engineering per se. But then they have the for the AME. For the AME. I think you can do it through KDU, right? Not the AME license per se that you have to sit for the exams at civil aviation, but from KDU you can do the course, right? So you can look that up. I'm not exactly sure about the engineering part. So if you want, I can look. Yeah, KDU. So if you want, I can look that up for you and let you know if you want to do an AME that way, right? So I I think I'll look this up somewhere tomorrow. When I go to work tomorrow to the airport, I'll look this up and inform Nirodha so he can pass the message to you. I think yes, KDU should have it. Uh, my contact details I have shared with Nirodha, so you can Nirodha is if there's anyone here who needs the contact number for anything, you can pass it to them.
Okay.
Right, that's it, I think.
Okay then. Yes. So, first of all, thank you very much, Aya, for enlightening us on these topics. I'm sure we can all agree that was a fantastic explanation that we won't be forgetting anytime soon. Thank you.
No
And
problem.
on that note, I would like to deliver the vote of thanks. Today's event would not have been possible without the help of some very special persons. So I would like to thank our principal, Mr. PASP Jayalat, Senior Master of Clubs and Societies, Mr. TDCP Amratunga, our teaching charge, Mr. WHAD Sumanga, members of the Prefects Council of Royal College, and also a very special thank you goes out to our chief guest, Mr. Santhusha Ravihara, for taking time out of his schedule to share his knowledge. And lastly, I would like to thank everyone here for their participation today, and I hope you have a very pleasant evening. Thank you.
Yeah, good night, Aya.